Welcome back. This is an Aleks training video on counting the electron shells in a neutral atom. So, a lot of this is very simple. You've already done many times. If you were to look at, say, bromine, how many protons are in bromine? Well, bromine is number 35. Its atomic number is 35. So its number of protons is 35. So it would just be equal to its atomic number. So I would do the same for fluorine. Fluorine is 9 protons. Chlorine is 17. Okay. So how many electrons am I going to have? Well, this says it's a neutral atom. And if it's neutral, it's going to have the same number of charges, negative as positive. So if there's 35 protons, there's going to be 35 electrons, 9 electrons, and 17 electrons. Okay, so far so good. This is easy. Valence electrons. Valence electrons, remember, is how many in the outer shell. How many in the outermost shell of that. Okay, so you'll have to look at a periodic table. Please look at a periodic table. You're not going to understand this if you don't. Anything in the first column, okay, the first group, is going to have positive, is a 1 valence electron. There's 1 in its outer shell. Anything in the second group is 2. That's the beryllium group. Anything in the third group, boron and aluminum, that's going to be positive 3. Okay. The valence shell for carbon is going to be 4. Okay. The valence shell for nitrogen, the nitrogen group, is 5. Do you see how they're just next? The one for oxygen group, which is group 6, column 6, is 6. There's 6. The fluorine group is 7. And the helium group, the noble gases, is 8. So these are called representative elements. Remember, I've kind of skipped scandium through zinc, that middle kind of valley, I've kind of skipped it. I'm only looking at the first 2 columns and the last 6 columns. So the first 2 and the last 6 are representative or main elements, mainline elements. And so they will be your valence. Those 8 columns will be your valence shell. And there's like a limit of 8 valence electrons. So what group are these 3 in? They're all in the same group. They're all in group 17. Okay, that means that if you skip scandium through zinc, it's in group 7, and there are 7 valence electrons. There's 7 in bromine, there's 7 in fluorine, there's 7 in chlorine. Okay. Now but they're not all the same. They're not just because they have the same valence electrons. Their chemistry is going to be very similar. Bromine is going to do the very same stuff that chlorine can do chemically. Because of the valence electrons, chemistry is kind of camps out in valence electrons, either sharing or stealing. Okay. What about the number of shells? The shells is the row on the periodic table. What row is it in? Okay, because the first shell is going to be the hydrogen helium shell that's full at 2. And then after it's full, it has to go out and make a new shell outside, kind of a nested shell. So once it gets to lithium, it starts building a second shell. And when it gets to neon, it's got 8 and it's full. So then the third shell starts, that's at sodium, and it starts building sodium, magnesium, aluminum up to argon. Okay. Once that's full, it gets into group the row 4, period 4, potassium and calcium, and it goes all the way through the scandiums to gallium, germanium, and eventually bromine. So all you're doing is looking for what period it is. What period is it? Okay, so the first one, bromine, is in period 4. Okay, so it has 4 electron shells, each nested inside the next. Okay, 4 going outside and again, and outside again, and outside again. Fluorine is in that second one, so there's only 2 shells there, and chlorine is in the middle with 3 shells. Okay. Now, this is very, very simple, but understanding this allows you to answer lots and lots of questions. That's why we're making you do it. Okay?